NASA's billion-dollar investment has proven to be a mighty asset that is doing precisely what it was built to do: to understand the earliest stages of the universe in new and exciting ways, to eventually help us understand and trace back our own origins. After recently discovering 6 megagalaxies that formed when our universe was a hot dense soup, researchers have been itching to keep testing and flexing Webb's capabilities. And every observation keeps yielding results with more and more distant and ancient galaxies, each with unique properties. But what happens when we discover organic material, including the building blocks of life, in one of these ancient, early galaxies? A breakthrough that changes everything we know about our cosmos.
Orbit. Beyond the blue.
Astronomers using the James Webb Space Telescope have detected the most distant known organic molecules in the universe. It's the first time we have ever detected complex molecules in the distant universe. These complex molecules were found in a galaxy known as SPT 41847, located more than a dozen billion light-years away. The universe is some 13.7 billion years old, so this galaxy is ancient. This structure, which looks like a cosmic smoke ring, is evidence of complex organic molecules, similar to smoke or smog in the distant galaxy shown here. This discovery sheds light on the chemical interactions that occurred within the earliest galaxies in the universe, and how they relate to star formation. On Earth, the molecules, called polycyclic aromatic hydrocarbons, can be found in smoke, soot, smog, engine exhaust and forest fires. The base of the organic molecules is carbon, considered to be one of the building blocks of life because it's a key element in amino acids, which form proteins. The light from the dusty galaxy began traveling across the cosmos when the universe was less than 1.5 billion years old, just 10% of its current age of 13.8 billion years. Using Webb's infrared capabilities, which can see light invisible to the human eye and peer through cosmic dust, Webb was able to capture new details about the galaxy. And the Space Observatory received a helping hand from a phenomenon called gravitational lensing. This magnification happens when two galaxies are almost perfectly aligned from the Earth's point of view, and light from the background galaxy is warped and magnified by the foreground galaxy into a ring-like shape, known as an Einstein ring. Gravitational lensing was originally predicted by Albert Einstein in his theory of relativity. That level of magnification lets us see all the rich details of what makes up a galaxy in the early universe that we could never do otherwise. Astronomers spotted the signature of the organic molecules during a careful analysis of Webb's data. The unexpected finding is helping astronomers piece together answers to some of the lingering questions about the beginning of the universe. It's amazing that scientists can now identify molecules billions of light-years away that we're familiar with here on Earth, even if they show up in ways we don't like smog and smoke. Ever since it was launched, James Webb has been making headlines for eyeing thousands of colossal galaxies. Now, these shocking new findings made by the James Webb Telescope could change everything we know and force us to sit up and reassess all our cosmological theories. Groundbreaking discoveries that could change everything. Continuing on its streak of making discoveries that question the Big Bang, the James Webb Space Telescope has found the most distant galaxy cluster ever seen, at 30 billion light-years away. Researchers say it's probably one of the biggest clusters in the universe by now. All 7 galaxies in the clump had been observed before with the Hubble Space Telescope, but scientists didn't know how far away they were, or whether they were truly bound together. Because light takes time to travel from distant objects to JWST's position orbiting the Sun, the telescope sees these galaxies as they were about 650 million years after the Big Bang. As we currently see the protocluster, it appears small. But if its light could reach us instantaneously, letting us see what it looks like today, it is very likely it would be colossal, having gravitationally roped in thousands of other galaxies. The researchers' simulations hint that this protocluster may now be one of the most enormous clusters in the universe. Recently, the James Webb Telescope also discovered a minuscule galaxy 13 billion years in the past that has given rise to new stars at an exceptionally high rate for its tiny size. It is said to be the smallest galaxy ever discovered at this distance. In a groundbreaking discovery, a team of researchers from the University of Minnesota used the James Webb Telescope to peek into more than 13 billion years into the past, to discover an extraordinary tiny galaxy that has generated stars at an extreme rate for its size. This tiny galaxy is one of the smallest ever discovered at this distance, around 500 million years after the Big Bang. If this doesn't excite you enough, then you should know that this tiny galaxy could potentially help astronomers to understand more about the galaxies that were present millions of years ago, just after the universe burst into existence. This galaxy is far beyond the reach of all telescopes, except the James Webb, and these first-of-the-kind observations of the distant galaxy are spectacular, said Patrick Kelly, senior author of this paper. The galaxy is roughly a millionth in the volume of the Milky Way, but interestingly it is still forming the same number of stars every year. That is insane. If you wonder how the James Webb Telescope can observe such tiny details in a wide enough field to capture the entire galaxy cluster at once, it is mainly because of a phenomenon called gravitational lensing. Gravitational lensing uses lenses that bend and magnify the light of the mass present in the galaxy or galaxy cluster. Thanks to gravitational lensing, this tiny galaxy appeared 20 times brighter than it would have appeared. Mind you, this is apparently the first time it was possible to look into most of the way back to the Big Bang. And James Webb Telescope, with its galaxy hunting abilities, has made it look easier than ever before. So far, we have only 2 space observatories that are capable of creating deep field images that allow us to see the universe in unprecedented detail: Hubble and James Webb. Hubble operates in the visible light range, while Webb operates in the infrared. While both are taking views of distant galaxies in dim parts of the sky, Webb's images are clearer due to its infrared imaging abilities. When we compare the look of deep fields from each of the telescopes, we can see how much they differ. Images from Webb have their own unique look, compared to images from Hubble. This is most noticeable in the way that stars appear, with their distinctive 8-pointed diffraction spikes. This is due to the shape of Webb's mirror, and it will always be a signature look for all of James Webb's images. This ability of Webb's to see objects in infrared offers it a considerable edge over the rest of the space telescopes, including its predecessor Hubble. Many objects that remained unseen or had unclear visibility in Hubble's deep field image are now being brought to light, literally, by Webb. If things continue the way they were, 2023 is going to be filled with plenty more discoveries that change the way we see the cosmos. But what do I know?
Orbit. Beyond the blue.